with HARTING. We will be going to HARTING Headquarters in Elgin, Illinois for a live demonstration. The subject of the Hangout is kick hardwiring to the curb, savings through plug-and-play connector technology. At the end of the Hangout, you can tweet your questions using the hashtag DKHOA. We will now join the HARTING team. We have Corey Jenkins, Product Manager, Ed Garskowitz, Market and Applications Manager, Jonathan Skiba, Product Specialist.
Well, thank you for joining us. We're going to talk to you today a little bit about savings through plug-and-play connector technology, kicking hardwiring to the curb. I myself and Ed Garskowitz are going to take you through the main presentation. We have John Skiba here, the Product Specialist, who's going to take you through the hardwiring demonstration, which we have in front of you. We are then going to go to a live feed from our production floor to show you the short and quick and advantages of testing with the automated test equipment. We also have then video to show you the advantages. And at the end, it'll be wrapped up with a nice smartphone cost savings calculator app. And then we're going to have a summary and some takeaways, and after that we'll leave it 15 minutes open for Q&A. Thank you for joining us. So before we start discussing the advantages of connectorization, I thought I would explain to you the different types of connectorization. So on the left on the slide you see what we call connectorization on the outside of a cabinet, or the outside of your device, your machine, whatever you want to call it. On the right, what you see is connectorization on the inside of the cabinet. So you see some Ethernet, some board level connectivity, so on and so forth. So I just want to be clear that connectorization means different things to different people in different industries. So the point being, we're gonna try and touch on both, basically both concepts. So outside the cabinet and inside the cabinet. But what I also like to do is explain to you essentially the evolution of connectorization and also the evolution of hardwiring. Historically, hardwiring was used for power. Most machines only had power going to them. They weren't that smart pieces of equipment. But as evolution has happened, the machines become more upgradable, modular, serviceable, so on and so forth. So connectors themselves had to advance in the same fashion. So essentially, when you look at your equipment, your machine, your device, it's a computer. If you think about it, there's Ethernet, there's data, there's power, you name it. It's no longer just running an 8-gauge wire to power up your equipment. And that's why in the US, hardwiring is fairly prominent. But as you can see, connector evolution from the starting in 1945 all the way up through 2013 and 14, we've evolved in the same fashion. So from power to including Ethernet, signals, pneumatics, fiber, high power, and we'll show you some examples as we come through here. So essentially, connectors are problem solving for the real world now. You're no longer limited with your the connector capabilities. The connector capabilities allow the engineer to save himself some time and effort in the design.
Now, when we look at printed circuit board connectors or board level I/O, we see a similar development in terms of the connector product. From the through-hole connectors in the 1950s and 60s through the standard-based, rack-based, more robust connectors, starting like the DIN 41612 connector, for example, developed in the 70s and 80s, really allowed you to progress into more industrial, more medical, more defense-oriented applications. Now, as we move forward, similarly to what we saw outside the box, board-level connectors need to handle different media types, whether it's higher power, whether it's Ethernet, or it's analog RF signal, and connectors evolve to handle these types. Mixed D-subs, gain, coaxial connectors, for example. And now moving forward to today, as Corey mentioned, really connectors are allowing new things from a performance standpoint. If you need higher speeds, higher density, lighter weight, like an unmanned aerial vehicle. Connectors are allowing you to do things that you could never do before. And connectors are evolving to support more and more complex designs. So while this evolution, connectors have evolved over time, one thing has stayed the same. Connectors are an investment. Connectors cost money. These products cost money to design, to develop, to manufacture. And they cost money to purchase. You know, they're not free. But there is a but. The benefits far outweigh the upfront cost of the connector. And that's what we're going to spend the next hour explaining and enlightening you guys about.
So, to give you another example of what we consider hardwiring versus connectorization, I would just want to show pictorially what we mean, and this will lend itself right into the live demo you're going to see here in about 15 minutes. So the top is a hardwired example. So you see a control cabinet on the left, a control cabinet on the right, and wire going in between the two boxes with cable gland and terminal blocks on the inside. Standard hardwired scenario. On the bottom example, you see the same setup, but using connectors. Okay, so what we want to focus on clearly in this presentation is this portion, the connectorized portion, where the HARTING connector will allow you to disconnect the box, so on and so forth. So just keep this in mind when we are discussing. When we use the term connectorization, this is what we mean. So the way this presentation is broken out, and the way we like to explain this is you have considerations for using connectors, and you have advantages. So we're going to start with the considerations, or the upfront questions that you yourself might have. So as Ed mentioned, there's an increase in upfront material cost. Upfront material cost is the connector. Okay. So you have the hood. These are connector terms: the hood, the housing, the insert, the cable glands, the contacts, the Ethernet. You know, all these different types of connectivity that we have. USB, M12 for sensors, so on and so forth. There's a cost that essentially increases your initial bill of material cost. So the next consideration that you may ask yourself, and you should, as all companies will, is that there's upfront additional wiring costs too. Okay, so we know this, you know this, so at least want to show you what we're talking about, and we will address these topics as well. So at the top you have what we call the hardwiring time. Okay, you know this, your shop knows it, you can estimate this, it's a known time. How long does it take you to install your equipment or to hardwire it in your factory? Okay. On the bottom, you have the connectorization time. Okay, so what is this time? It's the time to add the connectors. On the picture I showed before, you have the hardwiring time plus the extra time to install the connectors. Then you have the cost of the connectors. So this graph is showing you on the top the initial hardwiring time versus the bottom, the entire time to connectorize plus the cost of the connectors. This is a known. We want to mention to you in this presentation that, and we're not going to ignore this fact. It's a key fact when you look at the advantages and the true cost savings of connectors. So we want to be clear that you make sure you do understand that point. And you know, we can. Some may ask, how do you know how much longer it takes to install a connector? Essentially, it's a percentage of time based off of your initial hardwiring time. We did internal cost studies and time studies that tell us that there's an average increased percentage to install the connector. So it is an assumption, but at the end of the day, the story is that there's additional labor. That's the point. Okay, now Ed is going to take you through some of the advantages here.
Yeah, let's talk about some of the benefits of connectorization. Obviously, their cost. What are the benefits? One of the first benefits is that connectors help streamline the engineering, design and manufacturing process. We know that in today's day and age, it's very rare that a complete system or a complete device is going to be built and engineered by the same team in the same organization. Typically, different sections or components of the device are designed by different people, whether that's internally in a company or whether that's externally sourced. So what connectors allow you to do is to support this design process where different modules, different people who have different levels of expertise can build different parts of the system, and the entire system can be brought together using connectors. OEMs can use standard components, control panels, motors, power distribution boxes. These can be built and wired, connectorized, prior to the complete design being finished. So you're able to do some upfront tests. You don't have to wait for the entire system to be completed without building some of the components. Okay, another advantage of connectors. Okay. And finally, connectors can offer cost savings through other solutions. For example, if you have a system or a board that requires two different types of media, you're talking about two different connectors. Well, why not combine those media into one single connector, saving piece parts, saving cost, and reducing risk because you have one less connection to make. An example of this can be found in a number of cases, but let's look at an LED panel display, for example. Now, an LED panel is built from a certain dimension, a certain size. But when a customer has their use of the panel, typically they're not going to use the cookie cutter size. They're going to have their own dimension. They're going to need to do what they want to do with that display wall. Well, now the manufacturer of these panels could hardwire all of the panels into the shape and size that the customer needs and hardwire to the controller for the LED panel. Now that's not going to work for anyone. It's going to be time consuming, it's going to be expensive. A much better solution and cleaner is to connectorize each panel so that they can be connected at the customer site and the customer can do it themselves. Okay, each panel requires power and Ethernet. So an even better solution would be to provide a connector that offers both power and Ethernet into one connection. So now you're simplifying the design, you're simplifying the install that much further.
Okay, another advantage. The title of this presentation is Savings through Plug-and-Play Connector Technology. So you have to realize some savings. Here's an area where you can reduce time, which is savings. So reduce startup times and needed resources. So what connectorization does is it allows you to design a truly plug-and-play system. You have less technicians, or in some cases, no technicians needed at the end user. You can design, test, build, and ship completely to your end user, and they can, plug and play the system. It's very simple. Using pre-wired and tested cable assemblies really means that there's no troubleshooting needed. I mean, in a hardwired scenario, you have to disconnect and reconnect in the field. What does that mean? That means you could miswire something. Okay? If it's a connectorized solution, that means your box is tested, the cable assembly is tested, whatever else it's connecting to is completely tested. So here's an example of a conveyor system on the bottom. On the bottom left, you're looking at a motor. On the bottom right, you're looking at what we call our power T system. It's a way to tap off a main trunk line of power. So what this allows customer to do is it allows them to design in start to finish efficiency in their design, meaning they can build the motor, ship it. They can build the whole tap line and ship it. Nothing needs to be tested in the field. Essentially, it's a true plug-and-play design. There's no mistakes. So this application, each section of the conveyor system is about 10 feet long. There's a motor in each section of the conveyor system. and our connectors allow you to make the modular, or make the conveyor system truly modular, to make it 30 feet, or in this case, you know, half a mile, I believe, was the length of this conveyor system. So just to imagine that if you had to rewire it, or if their end customer changed the length 2 days before they install. So it's really saves the engineers a lot of headache. So here's, I showed you before the last example of comparing connectors to hardwiring. So here's another example, taking it a bit further. So again, at the top you have your hardwiring labor time. But now, what you see has been added is the shipping and installation costs. Because rarely do you assemble something at your plant and ship it as a complete unit and never have to disconnect it for service or anything ever again. That's a very, very rare case. So we're assuming that you have to ship and install at a different location. Okay, so at the bottom again, you can see the connectorization labor time is still longer than the initial hardwiring time. But now look at the shipping and installation costs. They're smaller. So you can see as you ship and install this, you start to realize your savings. That's the point here. And this does not include, and I'll reiterate this a couple of times, these calculations do not include any auxiliary costs, hotels, travel for miswiring, contractual agreements if you install too late, so on and so forth. You know those costs better than I do because they're unique to your application, but there are costs there that are hard to calculate. Therefore, we do not include it. Our story is still the same, though. You still realize savings without those costs included. Okay, cost savings. There it is. So now what we're going to do is we're going to take you to, we're going to do a live demo here that shows you what we really mean by hardwiring versus connectorization. This box that you see on the left here is a connectorized version with connectors. On the right-hand side, or your left, I believe, these are cable glands. So we're going to take you through about 10 minutes and show you the hardwired version and the connectorization version, and show you just so you can think about the steps required to do certain things, and then the steps, just as importantly, that are not needed to do when you disconnect. So John Skiba is the product specialist, so we'll let him take over from here.
All right, so after talking about some of the advantages of implementing industrial connector technology as a replacement for hardware, as Corey mentioned, we figured it would be beneficial to show a demo that will take place of the steps that would include what it takes to hardwire a box, which is this box right over here, and the main steps it takes to connectorize this box you'll see right over here. Now this process takes some time to complete, so due to timing, I'm just going to go over the main steps it takes to complete this. And I have some pre-assembled parts already for this, just so I can get through all the main steps and give you a good overview of what this will take. So, looking at the main steps it takes when hardwiring a box, you'll be able to compare these steps to the connectorized box and clearly see the differences it takes between the steps. And for the initial startup time for hardwiring, you'll notice that the steps are shorter and quicker to complete. But over time, when you need to disconnect, reconnect, and test over and over again, you'll start to see the benefits of connecting coming in. So let's get started and go over some of the main steps it takes when hardwiring a box. First here I have some sample cable that I cut off, just 41 conductor 18 gauge cable that we're going to use for this demo purpose. The first main step that you'll use is you want to dejacket the cable to the proper length that you need.
See, some of these steps for the hardwiring and connectorization, some of these steps are used in both. So, for example, dejacketing the cable is something that you have to do for hardwiring and for the connectorization portion if you were to connect the cable separately.
All right, so once you have the cable jacketed for the hardwire part, you're going to want to group the wires and sort them to exactly how you want. Because when you place them through the cable gland into this box, I'll tilt it forward a little bit later on so you can see exactly, or you can see now exactly how it is. There's going to be some terminal blocks that will be very close to the opening of the cable gland and some farther away. So for organization purposes, it's nice to trim some of the wires to have some be the ones that are farther away in the terminal box, longer of course, and the ones shorter will be closer. I'm just going to cut a few here just to show this.
See, now this step, what John's showing you of trimming the wires for the terminal block on the inside, on the connectorization portion, it only has to be done once. You never have to unwire this box side here because there's a connector here. So once this, and this is we really talk about box building, making it clean on the inside is very important to not only the OEM but their customer as well. So it does take a lot of time to do the trimming of the wires to make it look clean. On the hardwiring example, this is something that you actually have to disconnect and then ship the box and then reinstall it. Well, in some cases, when you disconnect the wires, the strands become frayed and it requires them to, let's say, clean it up when it gets into the field. So there's some additional time there that you don't have to do twice in the connectorized.
Correct. So I just trimmed some of these back right now. I have a pre-assembled one that I'll switch to a little bit later so you can see the full product of it done. But going on to the next step that you'll need is after that, after you trim the wires, you're going to want to put on the labels onto each of the wires that you need so to avoid any confusion when you're doing this. So I'm just going to put a few on here just so you can see what this process consists of.
And this is like a cooking show. You have the finished version here.
Exactly. And I'll explain it, yeah. I'm just going to go over just the steps it takes for one wire or two, and then we'll switch over to here and you can see the final product done. So after that, after you label on here, obviously there'll be more that put on here, as you can see here. This is what it looks like. It's all labeled up. The next step is you want to strip the wires.
Now, what John's showing you here, he's doing a manual removal of the insulation. And that has to be done in the hardwiring scenario in some cases. When you talk about the connectorization portion, Harding has automated what we call strip and crimp machines that we manufacture. So what it'll do, you insert the wire, it'll remove the insulation, put on the crimp contact, and immediately crimp it in about 3 to 4 seconds or so. So it drastically reduces the connectorization install time, and it makes it more reliable.
So after I just stripped a few wires right here, going on to the next step is you want to crimp on some ferrules. Since these will be going into a terminal block, and depending on if you want to take it in and out and remove them, you're going to want to put on a ferrule, so you'll be able to do that in the process. So I place this ferrule on using this tool right here. I'm going to crimp it. I'm going to do a few right here.
In this process, the ferrules are required both on the hardwiring example and on the connectorized example. You can see on the inside of this box that there are also terminal blocks. So this is a mock-up example. Terminal blocks on the bottom here, terminal blocks in the middle. You can see that the setups on the inside of the boxes are similar.
All right, once you have that complete, I'm going to switch over to a more pre-assembled one I have here. And I can just show you and explain all the steps I just did. So here, as you can see here, the cable has been jacketed, all the wires have been cut to the proper length needed for the box, the wires have all been stripped, the labels have been put on, and the ferrules have been crimped on. So the final step that you'll need is you want to feed this through on the box that you have right here. This is the hardwire box I have. So I'm going to want to feed this cable through into the cable gland so we can start terminating these to the terminal block.
In a lot of cases, you can run the wire through first, run through the termination, or you can some people conventionally will run conduit, discrete wire. There's a lot of different ways to do this. But the point is that they have to be run through the cabinet and then terminated to a terminal block.
All right. right, as you can see here, I just ran it into here, and the first row we have over here is all empty terminal blocks. So after that, you want to look at the labels that you have placed on the wires and be able to terminate the wires in numerical order to the terminal block. So I'm just going to search here for the first label, find that. Going off the first terminal block I have right here, I'm just going to terminate it right on here.
So you can see what John is showing, that this does take some time to install
Gotta get a little more force.
the wires onto the terminal block. So this is the step, exactly what John's doing, that does not have to be repeated when you disconnect the cabinet machine and ship it in the field. You know, and in reality, what you don't see as well is when you're doing this in the field, sometimes there's noise, the lighting isn't correct, you can't read the numbers on here. People think the 9 is the 6, and they crisscross the wires, and I have to do some retesting of it, and that causes engineers headaches. I'll tell you an example. I had a customer use connectors. He saved a lot of money, but really the reason he used our connectors is because he knew that when he shipped his machine, that when he had to do a live demo on Saturday, that it was going to run. He had customers flying in from France, flying in from England, and contractually he had to make sure that it ran on that Saturday morning. And he said he didn't sleep. He said so he's going to use connectors so he can sleep.
Yeah, so as you see here, you tilted forward to get a better view, but the bottom one I have here is the one I have complete. Basically, once you put the cable through and then you start going through each one as ordered, you want to terminate, put all the barrels through all the terminal blocks and fasten down the cable gland that you have here, like so. And then you have all these completed right here. So this is what the complete version will look like due to timing. All right. So that's the hardwire. As you see, most of the steps are pretty straightforward and ones that you'll be familiar with. Doing this once isn't too time consuming, but the real problem comes when you disconnect this and reconnect it again and do it over and over again. So we're going to take a look at the connector box now first, right over here. We're going to go over the main steps it takes when connectorizing the box, and you'll see a lot of these steps will be very similar to the steps it takes for hardwiring, plus there will be some additional steps that you need, which will make the startup time longer, but although over time you'll see benefits of improved installation time, reduced maintenance costs, and reduction in downtime. So let's get started and go through some of the steps it takes when connectorizing the box. I'm going to break this down into about 3 different areas for you. The first part is the assembly that's going to be done on the hood part, which consists of the hood, the insert, the contacts, and the cable port. And I'll run through the assembly on that. After that, we'll go through the assembly it takes for the housing part, which will be the housing and the insert together, and then it'll be fastened to the box, as you can see, completed right here. All right. So I'm going to get started by starting off with the sample cable that I have here by de-jacketing the cable like I did on the first step for the hardwire. De-jacket the cable as so, and then the next step here, as you saw, I would strip the wires onto here, and after the wires are stripped, you then crimp on using the crimp tool that I have right here. You would crimp on the contacts, since the insert I'm using is the crimp version. I'm going to switch over to right now to a more finished version I have of this, just so you can see what that would look like.
This is the additional labor we're talking about, is that this end would have ferrules, okay, on the inside of this box. And this is the crimp contact version. So this is what you see. These are the HARTING crimp contacts. These are what get inserted into this connector. Okay, so you have ferrules, the crimp contacts that go to the connector. This is the additional labor that's required. And that's pretty much the main difference between the two, and you can show a connector there.
So yeah, as you see here, all of them, these are with the crimp contacts on. After that's completed, you're going to want to take all those contacts and insert them. The insert that you have, a couple out here pop tops to show this process. Once that's done, you have the hood here, which you want to insert the insert into the hood, fasten it down. That completes the assembly part for the hood. The housing end for it, all that needs to be completed is you need the housing that you have here, the mating half for that insert. And you want to fasten this down to the housing end right here. And once that's complete, you're going to fasten it down to the spot, the cutout part you have in your box, as you see here, all completed.
So to summarize, you now have a hardwired box. Imagine if you had to ship this box. You have to unwire all of the terminal blocks on the inside, ship the box, reinstall it. Okay? On this connectorized version, imagine this is the one that you are going to ship to your customer. Okay, so here's the HARTING connector. Okay, connectorized. Let's say you have to ship, disconnect, unplug, and ship. That's it. So that's what we're talking about when we say connectorization, the difference between these two. So that's what now we'll.
All right, we're now going to go down to the production floor to talk with industrial engineer Dan Gelfi and production manager to talk about the testing equipment, the quick demo, testing our wire.
Good morning. My name is Dan Gelfi. This is Abram Preece here. I'm just going to spend a few minutes describing quickly the benefits to testing a connectorized assembly as opposed to a hardwired assembly. You can see here, we have a short sample here of what you would typically see in terms of a hardwired scenario, where you're going to have your cable wired directly to your terminal blocks or to your panel or somewhere out in your floor, and on the other end could run any length, any distance. And one of the benefits to being able to test a connectorized system is that you wouldn't have to have multiple people and spread across great distances in order to be able to verify your assembly. With a hardwired system, you may end up having a few different people spread out over maybe even upwards of 100 feet or more, and having to talk through radios in order to verify that the system is built correctly. Typically what you would use is a multimeter, and you would have to spend the time to locate each individual wire and make sure that the other person on the other end has got the same contact pinned at the same time to verify that it is wired correctly. Once everything is done, you would have to then disconnect, coil up, and then package your system and ship it, and have to go through the whole process again and run the risk of potentially having a miswire and having to diagnose and troubleshoot out in the field. As you can see, it's taking Abram here a few seconds per wire, and it's not exactly the quickest method for testing a system. The benefits to a connectorized system, behind Abram, and in a minute you'll see it a little bit more clearly. We have an automated tester, which you can use single or double-ended systems or connectorized cables. Here's one. It's a double-ended cable assembly you see on both ends. What the benefit to this is that you could actually, once you've verified that you have one good cable assembly and you've tested it, measured it, and checked it all out, you could program an automated tester such as this one. And as simple as just plugging each end in, just let the tester run on its own. It'll test continuity, isolation. If necessary, you can also program it for high pot testing and insulation resistance. Here we go. Abram's going to run a high pot test here. Now imagine on a hardwired system, a high pot test typically checks the It'll check the resistance levels and verify that you're not going to get shorts between surrounding wires. So a manual test on a hardwired system, you'd have, where right now the automated tester is checking them automatically and very quickly, you'd have to stop and change your wire configurations for a high pot test on a hardwired system. And as simple as just unplugging and plugging in the next cable, he can be ready to test the next system. We also have the benefit of switching quickly between cable assemblies if you have multiple assemblies in your system. Here we have, could be a simple data or signal cable, Ethernet cable, another power cable. It's just a matter of scrolling through to the next stored test, selecting the program, plugging it in and letting it run. Now for our particular system, we can actually do AC or DC high pot testing. It will check isolation and continuity. But here where it's asking if we want to run the high pot test, it's giving our technician the ability to step back and away from the system so that as it's running a high voltage through the system, our operator can be safely away from it. And there's no danger or risk to the operator. So you can see here, we're going to be finishing up the test here in a second. These tests can be done very quickly, very simply. It doesn't take a skilled person to have to be able to know how to read a schematic or follow a pinout. They can just plug the system in, let it run. You'll get a pass, and you can go on and test multiple cables very quickly. All right, Corey?
Yes, sir.
Back to you.
PowerPoint. What we're going to do is we're going to show next. I'm going to show you a video. Before we start the video, what I want to set up the video and let you know that this is at the point where the boxes are already assembled. I've mentioned that it takes additional time to hardwire the connectors. Okay, so this is if you have designed your equipment and you're ready to ship it. Now what do you have to do? So take a listen. It's a minute-long video, short and sweet, gets right to the point. So.
In the scenario on the left, you have the simplified internals of an enclosure using terminal blocks. This system has been wired, and the video is detailing the disassembly of a hardwired system. On the right is the system using connectorized cables. For a simple enclosure such as this one, your hardwired system requires 9 minutes and 30 seconds to disassemble, compared to the 10 seconds needed to disconnect two connectors. Now you have the reassembly of the system, such as at the end user. This is obviously going to be a little more complicated, searching for the correctly marked wire for the corresponding terminal block location. With both terminal blocks terminated, one is just over 54 minutes and 22 seconds. Also consider the possibility of wiring errors during final assembly. Compare this to the 13 seconds using connectors. From this demonstration, one can see the time benefits of using a plug-and-play system. Connectors make rewiring, testing, and troubleshooting almost non-existent. This all adds up to cost savings for both the OEM and the end user.
Okay, I think the demo in that video really well showed the next examples, advantages of connectorization that we'll talk about, and that's reducing system maintenance and warranty costs and decreasing downtime. As you could see in the video, it is much easier to maintain, to repair, to replace a cable, to replace something on a connectorized solution than it is on a non-connectorized hardwired solution. So quickly, a couple other things to note with connectors. Connectors not only are easier to replace, but connectors can be designed for a particular environment, whether it's an outdoor telecommunication application, whether it's on a factory floor, whether it's a corrosive environment. A connector can be designed to handle that and to reduce the risk altogether of failure. If the part fails, a connectorized solution, a pre-tested solution, is much easier to replace, oftentimes does not require a technician or electrician. Whether you're replacing a cable assembly, whether you're replacing a daughter card, a board, much easier to do with a connector than a wired system. And then if you do require a technician, again, much easier to service. We saw from that video, much faster to service with a connectorized solution. The example here just shows a surface mount connector, but designed to be more robust for the harsh environment, this time connection on a robotic arm. So this connector is designed to prevent failure, and if it needs to be replaced, it can be very easily replaced. Now the last advantage that we'll touch on is improving customer satisfaction. This is something that cannot be understated, can't be ignored. Your customer will much more likely be a repeat customer if he's happy with the product that he or she has versus if they feel stuck with the product because they have no other option. Now, how can connectors do this? All the things that we talked about today. Connectors can make equipment easier to use, easier to modify, easier to install, easier to maintain. So all of the advantages we've spoken about today can help increase customer satisfaction. One other thing that we shouldn't overlook is that connectors can help your system, your equipment, have a cleaner, more polished look to the overall system. Take, for example, this rack on the right, this hardwired, I won't comment on it, but if you were a customer, would you rather work on this system here or this clean, connectorized system? Good answer.
So same topic as what Ed was mentioning. You're able to improve your customer satisfaction by combining different technologies into one. I mentioned in the earlier part of the presentation that connectors have evolved and are able to handle the new demands of different markets. Well, historically, if you had low power, high power, coax, fiber optics, Ethernet, pneumatics, bus communications, Profinet, USB, you name it, you had to use separate connectors. So think about that. We said in the beginning that machines are becoming essentially large computers. You have to bring all these different types of media into the machine, currently probably in different locations or in different cable glands, because you're limited to some degree by the connectors on the market. Except we call this our HAN modular connector. You can combine all of these different types of media into one connector. So it makes it clean, easy to use, less number of, or minimizes the number of disconnection points on your equipment. Okay, so we have about 50 different modules that can handle pneumatics, fiber, power, D-sub, shielded D-sub modules, all different types of termination styles. And this is one of our largest growing product lines simply because it makes the engineer's job easier, to be honest. And it saves a lot of people money. And this is essentially, to keep it simple, it's you create a custom solution with off-the-shelf components that are in inventory. So you can design like a Lego system, your own connector. It's very, very, very beneficial. I always use the example of, you know, an engineer may be reluctant sometimes to go from hardwiring to connectorization because they'll tell you that their electrical schematics, they can't solidify those early enough in the design process to say I want to use this specific connector with these specific number of pins and wire gauges, because the controls engineer might want to add another safety circuit to their system a week before it's going to ship. Well, with this HAN modular series, you can leave blanks inside the connector, and you can add one of the 50 different modules and easily implement this new circuit to it. So it really makes connectorization useful and viable for for a lot of engineers. So we are, in that vein, we have created a connectorization savings app for your smartphone. It's going to be launched in September. It's in the development phase, almost finished, but it's going to show you everything we talked about. You have to enter the cost of hardwiring, which you know you can estimate. You then can enter the cost of the connectors. And you can play with these numbers. You could say, okay, what if the connectors were $50? What if the connectors were $150? You know what? It takes me 4 hours to assemble, so that's $60 an hour. Maybe it's 70, maybe it's 30. It doesn't matter. The app doesn't care. You enter the numbers on what you think is correct, and what it'll do is it'll calculate the connectorization savings. Okay, so what you see on the bottom left are the initial costs that I mentioned, the cost of the connector and the cost of hardwiring. The next one is the initial assembly costs. So you see the cost on the right is higher than the initial hardwiring cost because we said it costs more to assemble the connectors, which is true. Okay, so these are all quote-unquote facts that you, the customer, can enter. Okay, so what does that mean? We mentioned a few times that you save money the more you disconnect or reconnect, or disassemble and reassemble, or ship, or maintain, or replace a motor, you name it. So in this scenario, it shows that with the very first disconnect or reconnect, you save $19. Okay? If you do that again, you're now up to $112 savings, and so on and so forth. So the point is, you save money on your very first field installation. I mentioned before that this calculator and everything we've shown you does not include the cost of your engineer to fly out there. It doesn't include weekend stays. It doesn't include any contractual things like we mentioned. So this is purely based on an installation cost. And to be honest, the other costs that I mentioned are more beneficial than these, to be honest. Okay, so we're going to close with the takeaways. We're going to come back here live to the Elgin facility and do a summary for you. John has shown you a few things. Ed has mentioned a few slides, but in summary, what it means is, what does connectorization really mean, and why should you use it? What it really does is it improves your competitive advantage and your profitability. Okay, that's why we're here. That's why HARTING does what we do. So the reason, or one of the ways that the customer can increase your competitive advantage is by the modular design, by the process efficiencies that we talked about, the improved aesthetics of the equipment. You know, that showed the board that was clean. Okay, you look at these. This is a lot cleaner than this. We've designed a bunch of other newer connectors with different looks that are used in certain markets where they just like the shape of our connectors. So, you know, we're improving our product and listening to the market as well for stuff like this. So, similar to the story that I showed or mentioned before, you're really reducing the unknown. Okay, as an engineer, if you're an engineer, you know that that's the worst thing that you could do is not take away the unknown, because if you install this in the field, you could have wiring mistakes. Okay, that makes you nervous. You want to ship a connectorized solution that you know, after you have designed it, you can test it and ship it, and no one has to open it. Okay, you can do the same thing with the cable assemblies. Let's say part of your equipment is made in the U.S. Well, maybe part of it's made in Canada, maybe part of it's made in Poland or Germany or China, and it all has to be shipped somewhere else. That's a lot of risk. Something can happen. There's miswiring mistakes, warranty costs, servicing costs, you name it. That can all be minimized by using time-tested, proven connectors. So with that, what we'd like to do is ask you to review your equipment for opportunities for connectorization. Are there areas on your system that are modular? Do you need to replace something? Look at those areas. Anytime you need to disconnect something and reconnect it, that's where you should look. So we have a team here at Harding full of application engineers, and there's also a great team at Digi-Key that can help you with application assistance. I thank you for your time. Thank you. And I think we're going to open it up to a question and answer period.
Yeah, Alex, did we receive any questions from the viewers?
Yeah, you mentioned the possibility of combining multiple cables into one connector. How are the multiple cables handled?
Good question. There's a couple different ways you can combine cables. Okay, it depends on the scenario. If you're using literally that cables, a jacketed cable, we have hoods that have multiple openings, so you can bring 2 cables, 3 cables into a hood. So, for example, this is a hood, a connector hood that has 1 opening. Grab another connector. I can show you. This is a connector with a cable opening on the top. Okay, you can bring another cable in through the side or this side. There's also cord grips. This is a cord grip that have multiple hold glands on the inside. So if the cables were smaller, you could fit 2 cables inside of there. That's one scenario. Another scenario is if you're currently using conduit, okay, whether it's plastic or metal, it doesn't matter. You can run conduit into the Harding connector and use your discrete wire just like you were, or you can use a combination of the discrete wire. You can run, let's say, 10 8-gauge wires or 10, 15, 16-gauge wires along with a shielded Ethernet cable into one of our modular connectors. So you can still use your conduit system if that's what you like. So there's multiple ways that can be handled, for sure.
Any other questions? That's all?
Okay, that was all.
Okay, well, thank you for joining us again, and I'll turn it back over to Digi-Key. Thanks from the Harding folks. Thanks a lot, guys. Take care.
Thank you for joining Digi-Key on this live Google Hangout with Harding. Please register for the prize using the keyword modular. Thank you.